Here's some examples and how these principles can be applied as shortcuts. The next examples will show the work energy theorem and the impulse momentum theorem to solve problems quickly. Note that these problems can also be solved by using F equals ma and either the no time equation or the velocity as a function of time. We are going to be looking at a car entering an on-ramp, a parachute slowing down a skydiver, a ball thrown upward, and a brake test. All very familiar situations, right? So here we go with a car entering an on-ramp. A 1,000 kilogram car moving at 20 meters per second needs to accelerate to 30 meters per second while traveling up a 500 meter freeway on-ramp. What net force is necessary to make this happen? So remember your strategies. Think about, the important information that you're seeing here. We know that this is a mass. We know that this seems to be an initial velocity. We know that this is a final velocity. And then here is our displacement. What net force? So we're looking for F net. All right. The work energy theorem, because we need to relate force and distance. The strategy that we're going to be using, which is the final energy equals the work done plus the initial energy. Our final energy, we're moving, we have a velocity, so 1/2 mv squared equals the force times the displacement. We need the force and we have the displacement, equals our initial kinetic energy. Plugging in our numbers, substituting there, and then solving for F. We have all of that into the calculators, and we finally get F equals 500 newtons. Not too bad, right? So we have force, we have displacement. The only relationship there is work. Then we have velocities. So now we're dealing with energy also. So we're taking everything in. It's important to identify the type of problem that we're dealing with. So that's why I keep going over the specific variables that we have and the relationships there. That's going to be one of the trickier things that you're going to have to do this year, is determine what type of problem is this. Because obviously dealing with a force problem is very different from dealing with a kinematic problem. I mean, it's the same type of feeling. We're writing out the information that we know. This is what we don't know. And then we're picking an equation. And that picking the equation can sometimes cause problems if you're having trouble identifying the type of problem. Okay, so it's important to remember these relationships. Moving on. If we solve this using motion and forces principles, we'd have to use the no time equation to solve for acceleration, plugging it in. You can check this if you like, but you'll see that it's a lot more intensive. We're going to use the net force equals mass times acceleration. So then we would just multiply the mass times acceleration. So really you can do it any way. Physics still works regardless. But I feel like you are going to make less mistakes by using this work energy theorem. Especially because this equation has squares and you're going to forget the squares. All right, let's look at a parachute slowing down a skydiver. 50 kilogram skydiver moving downward at 60 meters per second needs to slow down to 10 meters per second during the course of 2 seconds. What net upward force must the parachute provide? Impulse momentum theorem, because we're relating force, the net upward force, to the time, 2 seconds. So our final momentum equals impulse plus the initial momentum. mv equals F delta t plus mv naught. Plugging in where downward velocity is negative. So our initial velocity is 60, negative. Our 10 is negative will give us a force of 1,250 newtons. So that's impulse momentum theorem. You can see the temptation to use kinematics, those motion equations, because that's what you learned first. But don't be too comfortable with those. We blew right through those, right? Be more comfortable with impulse momentum theorem and work energy theorem. If we solve this using motion and forces, we're going to use this to solve for acceleration, and then plug that into net force equals mass times acceleration. Ball is shot upward from the floor with an initial speed of 30 meters per second. How fast is the ball moving when it strikes the ceiling 25 meters above? Work energy theorem, because we're relating force and distance. Final energy equals work plus initial energy. Final energy equals work plus initial energy. Force is mg, which is the weight. And work is negative because the force is down while displacement is up. Pause there so you can kind of digest that. So it seems as though there's not a force that we're dealing with. Well, we can assume that this is happening near the surface of the Earth, so that means the object will have a weight. So we can use that weight to work for us. And we get velocity is 20 meters per second in just one equation rather than using two equations. A 2,000 kilogram truck can apply 10,000 newtons of force. How much time does it take for the truck to brake from 30 meters per second to 10 meters per second? We have a force and we're talking about time. How much time does it take? So you tell me, what are we doing? That's right, impulse momentum theorem. We're going to call forward positive, making the braking force negative. Final momentum equals impulse plus the initial momentum. mv equals f delta t plus mv naught. And then just plugging in and solving for t. And that's it. That's all we've got. Not too bad, I don't think. Make sure you're doing practice problems. I can't stress this enough. Do the practice problems.